Good day and welcome. Today we're going to have a look at semester test 2, where we're going to work in 2D to 3D conversions, where you have a DWG file that's been thrown in some other type or some other CAD format. To use the data available on that CAD document to DWG file to create the part and then make changes to the part using synchronous modeling. The first thing would be to open the part. Okay. Then for us to import the data, we can either import it to the 3D environment or to the drawing environment. So drawing environment, you can select our template millimeters. Make sure that this button is checked so that you can specify where you want to import the data to. In this case, you can either model, 3D view, or sheet. In this case, we want to import it to the sheet so that we can assign the different views. Okay, the rest can leave it as default. Next thing it will be to identify what type of projection system is used. In this case, we can have a look at this dotted line here. This indicates that it's hidden detail, and for that to be hidden, it means it must be underneath the solid line. So you can't see that. If this was a solid line, it would have meant that you would have seen it if you look from the top. So in this case, this would be the top view, then this would be the front view, and then that would be a right view, then which make this whole system first angle projection. Next one is to select all the edges and then right click and move to new view. In this case, it's been specified that the scale is 1:2, so you assign the scale where you assign the scale. Yeah, so just select the objects. It would be a front view. Okay, this would be our top view. It's important that you make sure that you assign the right scale to all of them, right? So you don't change the sheet format here, you leave it as 1:1. Yeah, so you rather just change it here, then you will get the original dimension. So if you ever measure these things, it would be half scale, and so okay. So next thing will be is to copy our views to the 3D environment. You can copy individual curves, but in this case we want to copy in the individual or all views that were assigned. In that case, all views are collected. We can just add with constraints. Okay, we see that one of our views were incorrectly assigned. Let's just try and fix it. Let's just delete this. Go back to the drafting. Okay, so we have two top views. This one must be edit. This should not be a top view, there should be a right view. Okay, so we can just copy to 3D. Let's hope this works. Okay, then we can see that our views are correctly assigned. Okay, so the next thing would be is to check whether all the sketch entities or all the views are aligned. In this case, we can see that it is properly aligned. In case it's not aligned, you would want to basically move this whole sketch upwards or downwards depending on what it will be. Normal case, you would take the measure tool, measure between distances, and then make use of the move object tool to basically move your object by the measured distance. You can use it dynamically at a distance depending on what you want to do. You can move it in the direction that you need it to move. In this case, everything is correctly aligned. We can just start. Next thing would be to devise a strategy on how you would approach this whole sketch. So basically build a base, and then from there extrude this section, then that section, and then of course all the radius and all the holes and stuff that will be created on the last step. So on the extrude, we can change our filters to region and boundaries. Then we can select certain regions that we want to extrude, right? In this case, we can see that the regions are not properly defined, so which means we must make use of another type of selection. So we can make use of the single curve selection. Okay, let's just do that. Okay, so we can make use of the single curve selection. Okay, just select them one by one. Okay. Okay, here we can see that there's some inconsistencies. This is basically because of the fact that we made the wrong selection. So shift deselect. Right now we can select it properly. Okay. So we want the direction to change. Make use of the snap to object to specify the end conditions. Okay. Apply. Next thing would be, let's change the selection filter to region and boundaries. Okay, let's see if we can do that. So in this case, I would just want to change it around. Okay. So again, snap to object. You can snap it. Snap to object. Snap it. Let's unite and see what happens. Okay. So now we have our base. Okay, but we realize that we actually want this to be a full extrude because we want to put in we want to make the holes separately. So you can just select this boundaries and regions. Okay. So far so good. The next thing would be let's just do this one. Let's do this one. Okay, our end condition here, just change this to change this to up until selected. Right. Okay, so the holes will be the last thing that we put in. Okay. Next thing would be to just change this again. Just move along the single edges. Okay. Change the direction. Snap to object. Okay. Apply. Okay, so if we have a look at our views, it's fine. So all the major extrudes have been made. So now what's left is just to put on some cutouts. So we can change again regions and boundaries. So this would basically be a extrude up until here. In this case you subtract. Okay. Just check this one. Okay, just choop. So we can subtract that. We can subtract these holes. choose until subtract. Okay. Remember to save. So we can do another extrude cut. Zero. Okay. So we have our hole there. Next thing will be is to make these holes on top. So we can just select them, select. It's important to select all the regions. Okay, there we go. So we have our full circles. Until selected. Start from there. Until extended. There we subtract. Okay. So the next thing will be is to basically go and check the measurements of these chamfers so that we can put that in. Just use an LSS tool, measure distance. We can measure the distance from there. Okay, let's measure with projected distance. Say from that point to there. Okay, let's measure distance. Projected distance. We're gonna do a measurement. So, okay, so it's 2 millimeters. So go to the top view. Just measure sample diameter 35, 39. So it means it's 4 divided by 2 is 4. So it's a 2 by 2. So it's basically a symmetric chamfer. So we can just go home chamfer. It's 2 by 2. So we select that edge. Same at the bottom. Apply. Okay. Next thing we can do is just make sure that all the views are aligned and we got all the details. We're just checking whether all the extrudes fit in within the sketches. In this case it's fine. We can just select the sketches and hide them. Thank you very much for watching. Enjoy NX.